Hi students, hope everyone is fine and sane. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in short range wireless communication. In this video we are going to see different types of antennas that is used for short range radio devices. In previous video we have seen only dipole and monopole antenna which is used for short range radio devices, and today we are going to see loop antenna, helical antenna and patch antenna, the features of this antenna and why it is used for short range radio devices. First we'll start with loop antenna, where you can see this is the loop antenna, and you can see the patch antenna and you can see the elliptical antenna. We have different varieties of loop antenna, we have different shades. Similarly, patch antenna have different shades. Similarly, helical antenna has different shades, right? And coming to loop antenna features, you can see the loop antenna can be a circular loop, square loop, or in any forms. You can see like this spring pattern as well. The popular for handheld transmitters, particularly it can be printed on a small circuit board, and it is less affected by nearby connecting objects, and that is why it is predominantly used. But the biggest drawback is it is very inefficient. That is, the efficiency is under 10%, right? But it is frequently used in small handheld remote control transmitters like toys, like that, right? So the efficiency is very less, so it can be used for small handheld devices. The radio resistance is generally below 10th of an ohm, and radiation resistance and hence the efficiency could be raised by increasing the number of turns. The radiation resistance and the efficiency can be increased by number of turns. As you can see here, the number of loops if we can able to increase the area of loop, then we can able to increase the radiation resistance and the efficiency as well, right? And the loop antenna, because of its low efficiency, it is very rarely used for UHF short range devices, but for page receiver, where we need low data rate and high sensitivity to help compensate for a low antenna efficiency, right? We can use it in page receivers. And one advantage of the loop antenna is does not require a ground plane, right? Whereas in monopole we see that there is a ground plane. Here we don't need a ground plane. And similarly, low power unlicensed transmitters, the low efficiency of the loop is not much a concern. So wherever the efficiency is not a problem, right? And if it is for a small handle devices, we can use loop antenna. And what is helical antenna? Helical antenna provides better results than the loop antenna. It is almost similar structure, but you'll have some geometrical variations, right? But still maintaining a relative small size compared to dipole and quarter wave length. Helical antenna will also be a small size, right, as compared to dipole and quarter wave length, right? Because here what we will do is we will have a winding of wire like a spring, so that it reduces the size, right? Like we will have a conductor, and where you will have a wire, like it will be coiled in the form of a spring, like the diameter and pitch are very much smaller than the wavelength. And the helical antenna, very important factor is the efficiency is less here, but the antenna is resonant for its length, but the radiation resistance will be very lower. The impedance matching to a transmitter or receiver is relatively easy in helical antenna, and in helical antenna both vertical and horizontal components are elliptical. Polarization is elliptical, and helical antenna should have a proper ground plane for the best and predictable performance, whereas in loop antenna we don't need a ground plane, whereas in helical antenna we need a ground plane, right? And as I said, it is polarized effectively, as it has both horizontal and as well as vertical component, right? These are the features of helical antenna. And very important antenna is patch antenna, where patch antenna is used for microwave frequencies, where it is from 2.4 gigahertz or higher, right? We have different structure, different form of patches, where it is square, circular, semicircular, triangular, annular ring, square ring, like this. These are some examples of patch antenna, where the patch antenna, where you will have a PCB board in one side and other side you will be having a patch, and that patch can be of any different shapes, right? And the maximum radiation is perpendicular to the board. And coming to the features, the length of the antenna, that the patch antenna, is very, very important, right? That is, the length is given by L is equal to lambda by 2 into root of epsilon. That is calculated as half of the free space wavelength divided by square root of effective dielectric constant, right? And it is actually less than a wavelength because of the fringing effect. Fringing effect, in order to overcome the fringing effect, we will have less than half of the wavelength, right? What is fringing effect? You can see the fringing effect, that bending of waves at the corners, that is known as fringing effect, right? And as long as the feed is in the center, we can overcome this fringing effect. What is feed? Giving power to this particular antenna, right? This is called as microstrip feed line. So if we give this feed line in the center, we can able to overcome the fringing effect. And this microstrip feed is convenient because it is etched at the border together with the patch and other components, so that it overcomes the fringing effect. The impedance of the feed depends upon the width of the patch antenna, and we can connect this antenna, like you can connect this antenna with the transmission line, 50 ohm coaxial line, by using this type of connectors, right? And you can see here, 50 ohm coaxial transmission line can be connected directly to the underside of the patch antenna, with the center conductor going to the feed point, right? That is, you can see this feed point, like below that we can have the connector where we can able to connect with the coaxial cable line, so that the center conductor will be going to the feed point, right? So this is about the patch antenna. So today what we have seen is, we have seen important features of loop antenna, patch antenna and helix antenna. All these antennas are preferably used for short range radio devices. Thank you, my dear students.